Wyatt. Yeah, please don't use your cell phone in class. Thanks. I made an error yesterday. I found out how come I made the error. I got classes off of a website from Great Britain. See how easy it is to find things on the internet that somebody thinks is true, but is actually not true for you? In any case, I looked it up on 17 different sources. Okay, maybe not 17. But I got Class A correct. Class A fires are typical solid combustible things like wood and paper. And, pardon me? Well, I'd say if you burn jet fuel, you're going to get ash. It's just in really smaller pieces. So I personally wouldn't use that definition. Class B are flammable liquids, jet fuel and aviation gasoline and engine oil. And Class C are electric. Sounds like paper and wood. Oh yeah. Easy fire. If you burn a road flare in the water, it keeps. And that's a small fire. Okay. So we're going to keep going there. Let's see. I need to harass someone not yet harassed. Let's see. I haven't harassed anybody in this row. Dominic, you look harassed. Well, I've harassed you. Dominic, it's your turn. What semester are you in? First one. Yay. Okay. So hopefully you can get this one. You have any questions about this question? Would you like any background information before you attempt to answer it? You don't think what? Okay, I'm ready. Go for it. Yes, excellent. So look at letter A. Is there usually a power lever for the APU in the cockpit that you can move it? Never done. Never, ever done. How about remains at idle and automatically accelerates? For an APU, Dominic, what's the difference between idle RPM and full power RPM? It's the same RPM. There is no difference. And what the RPM is, what is that RPM? About 100%. Man, it's like they wrote that FAA question just for me. Yeah, I need this row. Louis? I see you're taking notes. I didn't want to interrupt you. Did you finish writing? I know you're taking notes. That's cool. Louis? Sorry, your name. So it makes it easy to point you out and harass you. So, do you have any questions? Surely you have some questions. That's where you say, yes, Mr. Johnson, I have questions, and please stop calling me Shirley. Okay. Y'all are going to have to figure this out here before the end of the semester. So do you know what fuel scheduling is, Luis? Have you ever been scheduled to work? Yeah, this isn't the same kind of scheduling. Fuel scheduling is the fuel control unit is deciding how much fuel to squirt into the engine. The scheduler would decide that shift to get the fuel control. Do you know what a new varying pneumatic load is? Pneumatic, the air PU, having a separate compressor. And then electrical load. What would be providing electricity if there's an electrical load? What's bolted onto it? there's no batteries that are while they done. Do it. Say 0. Go ahead. You can do it. You can say 0. Okay, great. There you go. Electrical generators are built most of the time. So what on an 8 for electric? Don't worry, I'm going to on the text. Electrical generators do. They produce energy. That's correct. What kind of energy? Hydraulic energy, rotational energy, or electrical energy? Electrical energy. Yeah, that's correct. Okay. So it's bolted onto an APU that produces electrical energy. What's that thing that makes electrical energy? It is on a car. If you put it on a car inside the engine compartment, the battery. Okay. Now, if what charges the battery? You work on a lot of cars? Not so much. Okay. Have you ever heard of this thing called an alternator? An alternator is just one particular type. So on a car, what we call that thing on a car an alternator. Okay. There are alternators on. Speaking when we bolt these sort of things to jet engines, we don't call them alternators. We call them So, Luis, what's bolted onto an APU that provides electrical power? A generator. Okay, there you go. So they're talking off the APU and how much electricity coming off of that generator bolted to the APU. That is changing. That is varying. So, it's in the cockpit to control the APU. There's a manual lever in the cockpit to control the engine that propels through the sky. How about the APU tail? Is there a lever that says more fuel or less fuel or higher RPM? Are you shaking your head? Say yes. Yes, you're shaking your head because no, there's no lever in the cockpit. APU, RPM. It's all done automatically by the fuel control unit. Okay. Oh. Pretty good? Are you shaking your head yes? Yeah, B looks pretty good. Okay. C, aircraft main engine fuel control. The main engine fuel control is bolted onto the engine that's under the wing. Control that the APU have its own fuel control unit. It has its own. So what do you think of answer C? Do you like it or do you not like it? Okay, you're shaking your head. You're saying you don't want to answer that question? Do you think answer C is a good answer or a bad answer? I'm sorry? It's a bad answer. Okay, what did you... Is that a good answer or a bad answer? And how about, what did you think of letter B? Does anybody have any questions about this question? They left out an S. It should have said aircraft mechanics. If you can't read it from the back, I'll go ahead and read it for you. Aircraft mechanics were created because pilots need heroes too. Anybody in here have a pilot certificate? I'm the only one? Oh, sorry. Let's see, it's Kyle, right? Yeah, sorry. Everybody's going to beat you up at break time now. I'm just kidding. They're just going to kick you in the shins or something. Oh, except Kittrick. He's ready. I think he's doing one of these. I got lucky. I got my pilot certificate, and 6 months later, I started aircraft mechanic school. So I took flying lessons while I was taking mechanic lessons. So I'm not prejudiced for or against pilots versus mechanics, except every now and then when I think pilots are really stupid. I got my AMT in May of 1980, and I got my flight instructor certificate the next month in June of 1980. So, but I got my private pilot certificate technically at first. But I had a tour of this building before I started taking flying lessons. Does that count? Okay, see? I started working on cars. I changed the main bearings and the rod bearings out of a big General Motors V8 before I ever flew an airplane. Does that mean I was a mechanic before I was a pilot? I actually did that before I'd even driven a car. I was lucky. My grandfather retired when I was 7 years old, and so I ended up hanging out of his garage and fixing cars because he thought it was a sin to take your car to the shop. Of course, in the 1960s, how much of the work on your car could you do in your garage in say 1967? Pretty much all of it. Yeah, if you had a voltometer, that was your electronics that you needed. Yeah, I've got a voltometer. Woo-hoo-hoo. Okay, we're going to cover Chapter 10, and just in case, let me rephrase that. We're going to start on Chapter 10. It looks like I forgot to put the page on here like I intended. The first part of Chapter 10 is reciprocating engine stuff. I think it's like page 46 is where the jet engine stuff kicks in. So you know what? I got it in my office. I want you to be able to write it down. Yeah, it starts on page 10-46. So that's where the reading assignment starts. Okay. So one of the things I like about reciprocating engines on aircraft in the United States is that 99% of the piston engines out there in the United States on airplanes and helicopters are either made by Continental or by Lycoming. So I really only have to learn 2 manufacturers. But even better than that is that how they put their engines together are nearly identical. How you bolt cylinders onto the engine is all identical. Things together is essentially, using torque and all the tools on 4 or 6-cylinder Lycoming, cylinder Continental, almost all identical. In fact, they're almost all in my toolbox. I need very, very, very few specialty tools. And how the engine works and what kind of pressures are in it are the same. And 99% of the engine magnetos are either slick or bent. And so I only really need to understand, but how to operate is the same. But if I know how to fiddle with slick magnetos, then I know about 95% of what I need to know to mess with, to repair a bended magneto. Same thing for continental engine versus a Lycoming engine. The only real is how to do maintenance on a reciprocating Lycoming reciprocating engine is that when you go to, not the carburetors, but when you go to the fuel, the fuel injection systems, which is probably only about 10 or 20% of the piston-powered airplanes out there and helicopters, injection systems are very different. So that's, let's see, you'll get that next semester. Because I taught that in March of 16, so you'll get that in March of 18. So that's next semester. Who was here and survived me through fuel injection systems in March of 16, a year and a half ago? Nobody was here then? Maybe that's true. Okay. So you're still alive. Are the psychiatric treatments helping? And drinking strong alcoholic beverages? That's helping you recover from surrounding me as an instructor? Okay. All right. So the downside, therefore, to turbo engines is, if you probably have noticed, working on 2 or 3 different engines out in the shop during lab, that the way they bolt together and you can get really good and figure out how it all works and how to inspect it and what to do to it. You get to another engine and you got to start all over again. Does anybody notice that other than me? 3. That okay. All right. So it's going to be that way your whole career. Now the good news is, if you go to work at an airline, you're probably not going to have to learn 17 different jet engines. You're probably only going to work on 1 or 2. If you go to, maybe 3. If you go to work in the shop at an airline, you're probably going to just work on that 1 engine. Like I've been to, has anybody ever been to San Francisco International? Have you been to the United Airlines maintenance terminal? It's been in there? It's massive. Massive is an understatement, but I'll accept that. Oh, man. Football field wing repairs. Yeah, it's crazy. And they have engine overhauls. When I say engine overhaul, I mean every single. And so there are people, and all they do is take a big giant turbo engine or turbofan, and that's all they do all day long, is they disassemble the engine into modules, and often over modules come in and they put the engine together. Usually they put them together vertically, not horizontally. And you don't have to learn 17 different engines. But if you go to work at a general aviation shop, you're probably going to end up, let's say you go to work for, I don't know if it's still there, back in the day it was called Fresno Jet Center. You might be working on a lot of different business jets and turboprops, and then you might actually be working on 10 or 15 different jet engines. So the moral of the story is the second part here, is that you're going to have to follow the detailed procedures for each engine. I mean, like, one really small differences between spark plugs in all right. Cold section versus hot section. My guess is for the entire Asman, I guess the first part was electrical. It would be very easy to describe a list of engine parts. You can tell me which one. The inlet, I probably wouldn't call the inlet and the exhaust part of the engine. They're usually provided by the airframe manufacturer, in particular the inlet. But yeah, the compressor section, if you wanted to break out the diffuser just before it goes into the combustion section, that would be on the cold side. But now the combustion section, the turbine section, Most of the time, though, although this has lots and lots of parts on it, if it has been squirted into it and caught on fire, or it's any farther downstream of that, it's ridiculously hot, that's the hot section. If it's just prior to squirting in and getting burned, anything there and before that is the cold section, because it's relatively cold. And when I say relatively cold, let's see, I need another victim. I'm sorry, I can't remember the name. Last person in the ring. Right? All right, so you got 30 minutes of lecture left for the entire week, approximately. 3 hours and 35 minutes. Eric, so can you tell approximately, and I'm very happy for a wild guess, that if you've got a big giant turbofan in an airliner, the compressor on that engine, do you have a lot of stages of compression, or is there just a few? Not talking little, giant, 50,000 of thrust that you can stand in the intake and maybe not even touch the top. Well, compress. How many blades? How many? Yeah, you got a set of rotating blades and a set of stationary blades. So that's stages are in big giant jet engines. Not a little. Stage. What happens to the pressure of rotating? Stage. Does the pressure go up, go down, or stay the same? Down, but across the whole pressure higher by the time it goes into the. It goes into this thing where all these things are spinning around. Section called. I'll give you a hint. The word's up there. What's that section called? Where that? Huh? It's a set of rotating blades and then a set of stationary blades, and a rotating blades, stationary blades. All is that correct? Okay. Think of that word. Is nothing. Pressure. Or the same there. It's compressed. So if you had a PSI gauge and you held it in the air, what does it say? To the air. What is it? If you up to say 0, can you make that noise? Okay. All right, it's running. Now what is the compressor on a turbine engine? What does it do to the pressure of the air as in total, if you count up all the stages together? Is the compressor just before it goes into the turbine section, into the combustion section? Okay, see, all that training from Mr. Asman has done you some good. Turbine engine compressors raise the pressure a lot. Thank you very much. Somebody in there. Let's see. Louis, you tell me. temperature of the air as it goes through a compressor. So can you add them on a big giant? How many? Let's say it's in a 50,000. So, Valentino, what's the name of that gentleman right behind you? Who? Zuriel with a Z. Okay, am I saying it right? Zuriel? Zuriel, what do you think is the estimate if the outside air temperature on a standard day is 59 degrees Fahrenheit and it goes through 20 plus stages of compression and the air gets hotter just before it goes into the combustion chamber, before we squirt the fuel in and catch it on fire? What's the temperature of that air in a big giant jet engine? You think it's 59 degrees Fahrenheit? Okay. It's going to be, would you say, a really high temperature? Okay. Now, if we squirt the fuel in, is it going to get even, catch it on fire? Is it going to get even higher? Okay. But it's going to be a very high temperature. Okay. I've read about this sort of thing. And 1,000 degrees is a little too much. Yeah, but on a turbine engine that's got 20 or more stages of compression, you can expect between 300 and 500 degrees Fahrenheit. How hot is it? How hot does your oven need to be to cook chocolate chip cookies? Friedrich, man, he's just like, well, you knew it too. Yeah, in the high 300s. All right. How many people in here have never cooked chocolate chip cookies in an oven? Never. Okay, two. You can. I think it's okay to cook chocolate chip cookies in an oven. Also, you can bake them in an oven. Has anybody ever cooked baked on a dash car and feed an aluminum reflector behind it, and the infrared energy would bounce down and cook the cookies, and you could. Yeah, okay. It's way hotter than that. So 300 to 500 degrees Fahrenheit. We're talking inside of your oven hot. So how is it to touch the metal inside of your oven, Zuriel, if the temperature's at 400 degrees Fahrenheit? Are you happy about that, touching it with your bare skin? I wouldn't do it, yeah. So now, Amir. Sorry, I knew your name, so it was too easy to pick you. If you're going to take bleed air off of the compressor, is this cold air? Are you taking the air? That's correct. It is not. Not cold. Yeah, I know what you're going to say, so go ahead.
Okay, it's after compressing it, the temperatures go up. We use this to cool the hot section.
Yes, we're still going to use this air to cool the hot section because 500 degrees Fahrenheit is still way cooler than 2,000 degrees Fahrenheit. So very good. So here was the trick question that I thought was going to be tricky, but I think you're going to know the answer is. So the compressor section, is it in the cold section or is it in the hot section? It's in the cold section because compared to the rest of the engine, it's still pretty cold. Now let's say you take bleed air off of it just before it goes into the compressor. How hot is this temperature on a big jet engine? If you bleed air off of the compressor, but you at the end of the compressor, and you've pumped the temperature up and you've pumped the pressure way up. How hot is this air on a big jet engine?
It's like 500 or 600.
Yeah, several hundred degrees Fahrenheit. If it's a smaller engine and it doesn't have as many stages of compression, it might only be 200 or 300 degrees Fahrenheit.
It's good because after getting inside the combustion, it's easy to burn it. So
I think it probably makes it easier for the engine to run if the air coming in is already pretty hot. But I think if we could have that air come in at a high pressure and only at 100 degrees Fahrenheit, I think the jet engine engineers would be happier because it won't cool as well at 500 as it does at 100. But yes, I think it contributes to the ease of the engine burning. What I want to know is what are we going to do with this bleed air that's coming off of the compressor? It's 400, 500, 600 degrees Fahrenheit. What are we going to do with this hot air? Is it at a high pressure? Is it at a high temperature compared to the rest of the airplane? No, not compared to the rest of the engine. Compared to the rest of the airframe. Yeah, okay. So what would we do? What's one thing we could do with that hot air? Hot air coming off of the compressor. So if here's the jet engine, and we'll put a big giant fan on it. But here's the compressor section. And we got some turbines in the back, and here's the combustion chamber. So we're going to bleed air off right here. We're going to take air off of the compressor. And the fuel nozzles are right there. So the fuel hasn't got to the fuel nozzles yet. So this air, we're going to say it's between 400 to 600 degrees Fahrenheit. That's true. If we let the air keep going, we're definitely going to want it to mix around with the combustion gases and keep the inside of the engine too hot. But I'm talking about the air that we let out of the engine before it gets there. We're going to bleed air off of the compressor. Yes, can you name one system that uses this bleed air? Pardon me? The control systems for engine control systems. Yes, because you could use this bleed air to turn around and operate thrust reverser doors or something like that. So yes, the pneumatic, this bleed, another word for this bleed air. Very good. We could use it to start another engine. And that's pretty usually what happens is you start up that one engine with an APU, and then you start all the other engines off of the other engines that are running. Okay, thanks. All right, line maintenance versus shop maintenance. It also might be called line maintenance versus heavy maintenance. It also might be line maintenance versus depot maintenance. When I was in the U.S. military, I worked at a pilot training base in Del Rio, Texas. It was about 20 miles from the border of Mexico, Ciudad Acuña. As I can tell, I never went. I had a friend of mine that would go to Mexico on the weekends, and they would seek out entertainment. I was married with a kid. I didn't go to Mexico seeking entertainment. They did have a really nice get there. So now and then my wife or she along with us, and we'd go during the day on Saturday or Sunday. Go to the flea market. I don't remember what I bought there. In any case, we had done on the flight line a ramp where the airplanes were parked. At that base, they didn't keep the airplanes in the hangar at night. They were going to fly them the very next morning at 6 a.m., so they didn't pull them into the hangar. They did line maintenance out. And it could be as much as taking the engine out, putting the engine on. We saw about engines removal and replacements, engine R&Rs. At least two of them, they brought the engine into the hangar, but then they pushed it back out at the end of the shift. I think one of those, wasn't one of those 737s, they did the engine change outside? I think one of them they did the engine change outside. Okay. So it's line maintenance is not so much where you're doing it, whether it's out on the flight line, out on the parking ramp, or in the hangar. It's really talking about the complexity of it or how long does it take to do it. So effectively, line maintenance, here's one way to describe it. Most of the time, if it's line maintenance, you can get it done on the graveyard shift in time for the airplane to go flying tomorrow morning. So if you can take an engine back on, you could. If we want to start calling it heavy met or depot maintenance, it's not out of service for an 8-hour shift, but it's out of service for days. And it's pretty much always a heavy maintenance or depot maintenance or shop maintenance is going to be done inside of a hangar. And again, the aircraft is going to be out of service for days. And that's what I did. I worked in a hangar, and every 200 hours, the system they had going on was 200-hour phase inspections. Instead of once every 100 hours, we drag the airplane in every 200 hours and do a 200-hour inspection on it. So you could have called that shop maintenance, or depot maintenance. All right. So what you may have noticed, this one right here, adherence to technical protocols. Let's see. I need a new person. It's your turn. I forgot your name already. Nathan. Thanks, Nathan. I know, March was a long time ago. A year ago. A year and a half? Yeah, it was March of 16. Holy mackerel. Yeah, I've drank so much adult beverages since then, I can't remember a thing. So, Nathan, can you describe technical protocol in other words without using the word technical or protocol? What does technical protocol mean? Yeah, maintenance manual procedures. That's awesome. That's great. Yeah. So this keeps coming up over and over again. If I was working on a reciprocating engine out in a shop somewhere or on an airport ramp, and it was a Lycoming engine or a Continental engine, there was so little to know about how to do regular line maintenance for a year or two, I could probably go out and work on either of these engines and do 90% of that work and know that I'm following the maintenance manual. Because I'd done it 10 times, and I did it 10 times on a Continental, and I did it 10 times on a Lycoming. It's always the same. If I was doing 100 inspections on Lycoming, 100 inspections on Continentals, and I was doing 100-hour inspections, say, once a week, maybe twice a week, long way for me to remember what the spark plug torque is. Yeah, a couple of times, and I'd remember what it was. In fact, I probably would start remembering which exact spark plug is approved for a lot of the engines. If I worked at a flight school, think of it like this. Let's say you worked at a big flight school. Let's say you worked at TransPac in Deer Valley, Arizona. It's on the north side of Phoenix. TransPac has a whole bunch of Piper Warriors. They're PA-28s. You know that yellow Cherokee 6 out on that yellow airplane? Well, that's a version that Piper makes is a PA-28. Well, they buy 25 of the exact same make and model. So if you're doing 100-hour inspections on that, you think it take before you your head what the correct spark plug was. Not very long. How about was the little screw on the carburetor to adjust the idle speed? You think you'd do that once or twice? Remember which way to turn it so the engine would idle faster, or which way to turn it to an idle. Could you do it knowing that you were doing it just the way the maintenance manual said? What if you had looked it up the very first time, and then the second time you did it, you looked it up again? It's the exact same carburetor that's on these 30 airplanes, and that's all you do. You're shaking your head, no, Kittrick. You wouldn't remember, or you just wouldn't know that you were doing it right. The question is, you're adjusting the idle RPM. Well, you're saying an interesting sentence. Let's dissect that one. You said you're supposed to have the maintenance manual with you. So closed on your is with you. Is that good enough? You don't know. That's a fantastic answer. That's why you're in school, right? Because you don't know. So here, I'm going to tell you the answer. The answer is you have to know that you're doing it the way the maintenance manual says. It doesn't. If you read FAR 43, which tells you how well you have to do maintenance, the maintenance manual has to be and where it has to be open, or if it even has to be open. You just, when you sign off that logbook, when you sign off that maintenance entry, you're promising, I did this the way the maintenance manual said to do it. I promise. And everything works great. You're not swearing. I looked at the maintenance manual today. You're saying, I'm swearing I did it the way the maintenance manual said. So based on that data, if I'm adjusting this, because I work on, that's all I do, 5 days a week, 40 hours a week, is I work on the PA-28 Pipers. They're all I do. I turn the screw to the right, and that makes, and I turn the screw to the left, and that makes it down. After I've looked it up a couple of times in the maintenance manual, do you think I'm a member? Like 4 times in the maintenance manual. Oh, you. Let's ask you. You probably remember. Okay, so at some point, I think at some point you'd stop this manual where it says turn the screw to the right for higher RPM and turn the screw to the left for lower RPM. I agree with you. At some point, you turn the screw. I agree with you. I agree with you 100%. So I see your point. So I think the point you're trying to make is everybody is different. Point is going to be different than when you think you're doing it the way the maintenance manual says. I think you all have valid points. I think one is difficult, even if I hang out with you for 3 or 4 hours a day, to decide if you're complacent. All I can do is look at what you're doing. Okay. Would it be easier to, if an FAA employee walked in and doing a spot inspection, would it be easier? There would be no conversation. Years. It would be very difficult for the FAA to say, no, you don't. But I'm not going to stop from pulling the maintenance manual out, and I'm not going to stop anybody from opening it to the right page. Well, Mr. Asman has a valid point, and I think he's been inspected by the FAA more often. Get you into a habit pattern that is way better than the other way around. Not having the maintenance manual out and thinking that you're doing it right, that's terrible. Having the maintenance manual out and to make sure you're doing it right, that's a good idea, right? Yeah. The manual. So what you're saying is that a human, to a moment, known how to do it correctly, and then stop, and then at some point, slowly started doing it less than accurately. I think you have a valid point. I think you have a valid point. This brings up a good point, and I want 30 more seconds on it. You that gets to decide whether or not you're doing it right, because you're the human being that is signing the maintenance records. And the points brought up here are A, and you don't have the appropriate manual ready to go in some manner, and you've done it a long time, are you such a perfect human that you cannot make a mistake over the years, start doing it less than correctly? The answer is yes, you're a human, and yes, you can make a mistake. What are the techniques you can use to reduce or eliminate those mistakes? Does anybody disagree with what I just said? Okay. So the last thing we're going to think about on this slide is that you must follow the maintenance. Have we said that before? All right. I think we've had enough for one day.